Thunderstorms are storms with clouds or clusters of clouds that generate lightning and thunder. You need three conditions for thunderstorms to develop. You need warm air that is rising. The air must have sufficient moisture, and it needs to happen in an unstable environment. Thunderstorms are characterized by strong up and down movements of air. They frequently produce gusty winds, heavy rain, or hail. Thunderstorms occur in regions where maritime tropical air masses are lifted, for example by mountains, fronts, convergence, or convection. The highest frequency of thunderstorms in the United States is in Florida, where moist air is constantly advected by the sea breeze. We differentiate between air mass thunderstorms and severe thunderstorms. Air mass thunderstorms are short-lived. Usually they last less than an hour. They are self-extinguishing and scattered. The main reason for the lifting of air is convection, and they frequently occur on spring or summer mid-afternoons. Their cell sizes are typically less than 1 mile. They often occur on summer days. The development of air mass thunderstorms typically follows 3 stages. The cumulus stage is characterized mainly by updrafts. It involves the growth from cumulus to cumulonimbus clouds. Continuous supply of moist air causes latent heat release, which supports updrafts. The updrafts keep the droplets suspended in the cloud. At this stage, we observe a process that is called entrainment. Entrainment involves the influx of surrounding dry air. Evaporation causes cooling and produces different sizes in drops, and this process initiates the downdrafts. The mature stage is the most intense phase. Strong updrafts facilitate the growth of droplets. The clouds grow to the top of the troposphere. Falling drops facilitate downdrafts. Downdrafts leave the base of the cloud, and precipitation is released in form of heavy rain or small hail. Evaporation of droplets below the cloud base causes cooling and enhances the downdrafts. And finally, during the dissipating stage, the updrafts weaken and the moisture supply is cut off. Downdrafts and entrainment dominate, and the cloud will soon evaporate. This is how air mass thunderstorms look on a radar image animation. Air mass thunderstorms do not typically produce severe weather over a longer period of time, because precipitation falls into the updraft, and this way the downdrafts counteract the updrafts in the cloud. Severe thunderstorms often involve high winds, hail, flash floods, and tornadoes. They originate because the lifting of warm air along a front or mountain slope is supported by diverging air aloft. 10% of all US thunderstorms are severe thunderstorms. They can remain active for hours. We talk about a severe thunderstorm when winds are in excess of 58 miles per hour, or if they produce hailstones with a diameter of more than 0.75 inches, or if they produce tornadoes. Severe thunderstorms can develop if very particular atmospheric conditions persist over a large region. In contrast to air mass thunderstorms, up and down drafts within the storm do not work against each other, but support each other to intensify the storm. That can happen in the presence of strong vertical wind shears. Wind shear is defined as a change in wind direction or speed with height. As a result of strong wind shear, we get tilted updrafts that maintain their strengths and are not hindered by downdrafts. The updrafts can become so strong that they produce an overshooting top that is the result of the cloud top reaching into the lower stratosphere. Downdrafts produce dense, cool air that spreads beneath the cumulonimbus. The gust front is the leading edge of the outflowing downdraft. It acts like a wedge. It forces warm, moist air into this thunderstorm. The outflow boundary is named gust front. Turbulence of the rising air can produce a roll cloud. It happens when the clouds are spinning around a horizontal axis behind the gust front. A shelf cloud extends beneath the main thunderstorm cloud and signifies the arrival of the gust front. An example for a severe thunderstorm is a supercell thunderstorm that you can see on this illustration. It requires one large, continuously rotating updraft of a diameter that can be up to 30 miles. It is called a mesocyclone and requires strong vertical wind shear. Another reason for the development of a supercell thunderstorm could be a temperature inversion in the morning. That sounds counterintuitive because a temperature inversion, by definition, is a stable condition, and we say that thunderstorms require unstable conditions. However, a temperature inversion can aid the production of large thunderstorms by inhibiting the formation of many smaller ones. Inversion prevents the mixing of air. The heating of the lower air continues in the morning, but the hot, moist air is trapped below the inversion layer, which is also called a capping inversion. A capping inversion works like a lid on a boiling pot. Unstable air finally erupts explosively and produces large cumulonimbus clouds. When the conditions are right for the development of thunderstorms, they often develop in groups or clusters. These groups can take on two forms: squall lines or mesoscale convective clusters. A squall line is a narrow band of thunderstorms that develop along a front. We are looking at a linear band of cumulonimbus clouds that can last for many hours. It can happen along a cold front that is accompanied by upper air divergence in association with a jet stream. It could also happen in the warm sector of a mid-latitude cyclone. In this case, it works in form of a dry line. In a dry line, it is not the temperature difference of the two air masses that makes the big difference. It is the difference in humidity between the CT and the MT air mass that meet in the warm sector of this mid-latitude cyclone. Derechos refer to widespread, long-lived windstorms that are associated with a band of rapidly moving thunderstorms. We see a bow or spearhead-shaped squall line. The reason for this phenomenon is that we find descending air behind the squall line. Air descends possibly in form of a downburst, and this causes this particular form of a squall line. A downburst is a strong downdraft within a thunderstorm system. We differentiate between microbursts that have a smaller diameter and macrobursts with a larger diameter. The winds of these downbursts are comparable to weak tornadoes. The dropping speed can reach 200 miles per hour. No surprise that these downbursts are particularly dangerous for air traffic. In a mesoscale convective complex or cluster, we see many individual thunderstorms organized into large oval or circular clusters. This can happen in a group of afternoon air mass thunderstorms. In this case, the system is self-propagating because the downdraft of one cell interacts with the updraft of the next, so these cells support each other and develop into this intensity. We understand that thunderstorms are low-pressure systems that are characterized by surface convergence and that are promoted by upper air divergence. So we are looking for regions in the upper atmosphere that promote divergence. An area of upper air divergence is related to the jet streak, which is the section of extremely high wind speeds within the jet stream in the upper atmosphere. As air enters the jet streak, it experiences a sudden acceleration. As a result, for a short moment in the entrance area, the pressure gradient force overpowers the Coriolis force and the air swings to the north. This results in convergence at location 1 and divergence at location 2, which can result in surface convergence. We find a similar situation in the exit region. As the air slows down, the Coriolis force temporarily overpowers the pressure gradient force, and therefore the air swings to the south. That creates convergence at point 4 and divergence at point 3. So in summary, the right entrance area and the left exit area of the jet streak are characterized by upper air divergence and promotion of surface convergence and thunderstorms. Lightning refers to the discharge of electricity. We get cloud-to-cloud lightning, which is the most frequent form of lightning. The discharges occur within a cloud or between clouds. The sky is typically uniformly lit. The other form is cloud-to-ground lightning. This happens when negative charges build in the cloud base and they discharge onto the positively charged ground. The lightning flash refers to the total discharge of the charges in the cloud. The duration is typically less than 1 second. It flickers because it often consists of several strokes. Here are the different phases of lightning. First, we get the charge separation within the cloud. That happens if clouds extend above the freezing level and it involves movement of ice crystals and hailstones. The second step is the step leader. This happens when ionized air becomes a conductive leader. The air between the cloud base and the ground becomes ionized. The next step that you actually see as the flash is the return stroke. Electrons at the lower end of the conductive path move earthward first, then the ones positioned higher up. The lower part of the cloud is discharged. Charges from higher up in the cloud move towards the ground before we get the next return stroke. You hear a thunder because air in the conducting channel heats up to about 54,000 degrees Fahrenheit. Air expands explosively and produces a sound wave. You can estimate the distance to where the lightning occurs by comparing the speed of light to the speed of sound. Essentially, you see the lightning at the moment when the discharge occurs, because the speed of light is very fast, 300 million meters per second. However, you hear the thunder after the discharge occurs because the speed of sound is slower, approximately 0.2 miles per second. Therefore, if you divide the seconds between lightning and thunder by 5, you get the distance from the thunderstorm in miles.